Okay guys, update to our case study about the Holden Astra year 2000 fault code P0100. So that is the mass airflow sensor fault. So what happened is I put a new mass airflow sensor guys, but the performance of the engine didn't change guys. But the voltage coming out from the signal wire of the mass airflow sensor had changed. So I think we have a good mass airflow sensor now because we put a new one. But the problem guys is the ECM is not getting that value guys. So continue watching guys, so you will find out what I have discovered in this case study guys. So okay guys, continue watching guys. Hello guys, welcome again to another episode of Pinoy in Australia. Our new parts are here, is here guys, the mass airflow sensor. So this will be the part 2 of our case study of P0100 of Holden Astra year 2000. So it take I think how many days? 3 days before it arrived guys. So let's put this in the vehicle. Then after putting this one, we will check the parameter of the scan tools. We will check the parameter of the airflow sensor. Previously during the troubleshooting guys, in the parameter of mass airflow sensor there is 0 gram per second. So the mass airflow sensor is not really working during that time. So even the engine is running, it doesn't get any value guys. So I'm sure that once we put this one in, it will fix the problem guys. So let's go and install this one to the vehicle. Okay guys, let's continue diagnosing this vehicle. So our fault code is still mass airflow sensor P0100-2, mass circuit volume airflow circuit low input, and the other one is evaporative emission control purge control valve circuit open, and the other one is P0443-4, the evaporative emission control system purge valve control valve circuit open. So the other one is P0460-1, fuel level sensor current high input. So the one that we are going to concentrate, guys, is the one fault regarding the mass airflow sensor. So right now what I'm expecting is I have a faulty ECM. I had checked the wiring, I have checked the ground, I had checked the power supply, voltage output is present, but the ECM cannot find it. So let's go to the parameter. So let's erase first this fault. Read codes again. Okay. So live data. So we're going to pull out the parameter of mass airflow sensor, coolant temperature, intake air temperature, okay. So right now our mass airflow sensor is 0 voltage, and the kilogram per hour is 0. Coolant temperature is 4.27, that is 20 degrees. Intake air temperature is 30 degrees. So I'm going to start the vehicle now, and let's check the reading of the mass airflow sensor. Right now, guys, the engine is like going to stall. It's like going to stall. As you can see, the mass airflow sensor has no voltage reading and has no kilogram per hour parameters reading. So if we're going to check the voltage reading of the mass airflow sensor is 1.3, and the ECM cannot find it. It cannot read the signal coming from the mass airflow sensor. So I'm convinced that there is something wrong with our ECM. So this ECM of this vehicle is notorious when it comes to failure of wire band. Wire band is the one that connecting the electrical socket going to the PCB. So my plan right now is to pull out the ECM, open this ECM, and check whether I can repair the ECM. So right now 0 volts, but in the thing is 1.4. Okay guys, sometimes there's a value coming out from here, then it only show up for a few seconds. So what I'm really thinking is there is an open circuit inside the ECM. I'm suspecting the band wire that connect the electrical socket where we plug the harness, and the printed circuit board is faulty. So that the purpose of that band wire is to give continuity between the electrical socket going to the PCB. So you can see that sometimes there's a value, guys, see 0.904111. so sometimes it read, but the value of voltage doesn't match on the in the screen, on the multimeter. So right now I'm going to focus it, guys. So 0.68.7 maximum. Right here on is na 0.6594. Yep. So I think there's a problem with the continuity of the solder portion of that band wire. So once the engine get hot, that reading will disappear. So when I think when the temperature of the PCB become warm, it expand and it become open circuit. So right now it has a value, it got a reading. Now it's become 0. See, guys, disappear. So it's open circuit now. But our mass airflow sensor is giving signal going inside the PCM, or going inside the engine control module. So it backs again. So the reading is on and off. So there must be an open circuit inside the PCM. I already checked the harness. I have good continuity in the harness. What I did is I put 12 bolts on the other side, then I put a globe that has higher voltage, and the globe illuminate properly. So if there's an open circuit or there's a corrosion on the wiring, it won't be able to turn on the globe. So I use the globe of the standard double contact globe, 521 watts, 12 volts. So that globe usually we use it on the tail light and stoplight. So see right now the value is popping out. Sometimes it's in there, sometimes disappear. So maybe sometimes the contact of the band wire is good, sometimes it's bad. So that's the reason why we have a mass airflow sensor fault. So it's supposed to be, the reading is supposed to be steady. It's not supposed to be disappear then coming back, disappear coming back. So it disappear and it come back. It means there's an open circuit and the problem is intermittent, and that's the cause of our check light engine fault on the dash. So you can see there is a check light engine fault. There it is, guys. So I'm going to open the PCM and see whether I can repair it, guys. Okay, guys, before I dismantle the ECM and check the internal component of that ECM, I decided to open up the harness, guys. just to make sure that there's really nothing wrong with the harness. So this is the signal wire of the ECM, guys. Yep, I backproof that one. That's the green with stripe white. So I follow the wire. I cannot find any corroded parts, guys. Any damage harness. I cannot find any damage on the wire. So the wire is perfect. So this is the wire, guys. This green with white stripe. That's the signal of the mass airflow sensor. So I backprobe it, and I'm going to check whether this is a break. There is a break on the wire by doing a wiggle test, while my test multi-tester is on the continuity test mode. So it's buzzing right now, so it indicates that there is a good contact on the harness, on the signal wire from end to end. So I'm going to wiggle it and check whether there is a problem. So if that noise disappear, that beeping pa sound, it means I have an open circuit. So I'm wiggling the wire now. So it means I have a good continuity, guys. So there's no problem with the wire, guys. So even the contact inside, guys, there is no spread terminal contact on that socket, guys. So I have a good contact when it comes to connector of the socket, the terminal thing. So same thing with the socket of the ECM. So that's where I put the sewing needle, guys. I put a alligator clip on it, and it bustling perfectly, so it's not losing the contact, guys. So I'm confident that there is no wrong with my harness, guys, with my wire. So it proves that the problem is inside the ECM. So that TPS is sending a signal, but the ECM is intermittently receiving the signal. Sometimes it reads, sometimes it not. But once the ECM become warm, it loses completely the signal. So when it become warm, possibly the component become expand, or maybe the PCB and the contact wire is losing its contact when it become warm. Maybe that contact become open circuit when it become warm. So the soldered part expand. So there must be a crack, or it loses the contact of the soldered part of the PCB inside the ECM. Okay, guys, I'm going to check the terminal of the ECM side. This is the signal location, pin location of the mass airflow sensor signal wire. So as you can see, it's beeping. So I have good continuity from other end of the wire going to this ECM socket. So I already compare the tension of the terminal compared to the other terminal. See this one and this one, it has the same tension, guys. So I don't have any terminal tension problem on this socket, guys. So I will do the same with the force valve of the evaporative emission, because I have also fault regarding the force valve. It says open circuit, so the computer also cannot see the force valve. So I'm suspecting that there is also internal problem when it comes to continuity to the terminal of the force valve. So I'm suspecting that there's a problem with the band wire inside the ECM. So okay guys, I'm gonna check the other one. Okay guys, that is the signal wire, no, the control wire of the force valve of the emission control of the evaporative emission control. So that's the force valve. This is the control wire that I backprobe. Actually, it's not a backprobe. It's attached it directly to the terminal. So right now, that is the location of the control wire. That's the ground. It sends ground signal to the force valve to open up the force valve. So right now I have a good contact. I will try to wiggle it. So if I lose the beeping sound, it means I have an open circuit. So right now I'm not losing the beeping sound, guys. So it means I accidentally okay guys, it come up again. So guys, I'm not losing any contact, guys. The only reason why I lose the BPs, you know, it's not, I don't push really hard the needle, so it will not spread the terminal inside that socket. So if I wiggle this one, I'm not losing any signal, guys. So I don't lose the beeping sound. So it means that there is no problem with my wire. So this proves that there is an internal problem with the ECM. So it finally come up. So what happened here, guys, is the ECM cannot see the force valve, and also the signal wire of the mass airflow sensor cannot be seen by the ECM. It's losing signal. So there must be an open circuit internally inside the ECM. So right now, guys, I will proceed pulling apart the ECM and check if I can repair it. Okay guys, at this moment, guys, what I'm trying to do is I'm trying to get a sign whether I have a continuity inside the ECM. So what I did is I put the end of the probe of the multitester on the signal wire of the mass airflow sensor. So this socket is the one attached on the mass airflow sensor. Then I'm putting the other end of the multitester on positive and negative. So this will give me a certain voltage if there's a good continuity inside the ECM. But right now, as you can see, there is 0.1. Sometimes it drops to 0. So it means that I have an open circuit inside the ECM. So there is no uh, signal or voltage coming out from the PCM. So my next move guys, or my next procedure is to open up the ECM and insert the band wire of this ECM, because this particular vehicle guys, when it comes to ECM, this ECM is very notorious or very well known to failure in band wire inside the ECM. So the band wire is, it is some kind of wire that give continuity between the ECM socket and the printed circuit board inside the ECM. So I'm going to open up the ECM now guys. Okay guys, I have managed to open up the ECM and I have found out that there is two damaged band wire. So band wire, see guys, those like hair wire guys, those are the band wires. Those band wire connect the socket, electrical socket, go into the PCB. So on the other side guys, that's the electrical socket guys. That's where the harness is connected. So on each pin, they use a very tiny band wire, as size as the diameter is as size of your hair guys, head hair. So very tiny, and it is welded or soldered on those those tiny PCB guys. So I'm trying to repair it guys, but during the process of removing this insulation guys, see this is like a sticky thing, I damaged the other wire. So I decided to purchase the whole ECM. I can purchase it for $220 guys, and much safer to purchase a second hand than to repair it, because I don't have the proper tools for soldering those things, and I don't have the materials for replacing this sticky insulation. So this sticky insulation guys, this protect the band wire from shorting together, and it also protect the band wire from vibration guys. So because maybe too much heat in the engine bay and also on the component, the soldered portion of the band wire come up from the PCB. So those two band wire, I have two band wire come up from the PCB printed circuit board. Those two wires guys are belong to signal of mass airflow sensor, and the other one is the signal, the control wire of the ports valve of the evaporative emission of the fuel canister. So the fuel canister have a fault code of ports valve open circuit. So it keep looking, the ECM is keep looking for the ports valve, even there is nothing wrong with the with the ports valve guys. I had tested the ports valve, it is working fine, wire is good, it losing contact from the PCB guys. So once it lose contact, the computer cannot see the ports valve. So what I'm going to do guys is I'm going to purchase this PCB and wait for the continuation of this video guys. So I'm waiting for the response of the supplier of the parts, and I asked him whether the ECM that he's selling is plug and play, because the ECM that he's selling is as a Z18XE. It comes along with the immobilizer module and key antenna and also the ECM. So there are three parts on that component that he is selling. So ECM, selling ECM with immobilizer module and antenna for the immobilizer. So hopefully he will respond as soon as possible, so we can end up this video and put the new second-hand ECM, because I'm asking him whether the ECM that he's selling is plug and play, because I don't want to purchase a K code card. So the K code card is used for programming the immobilizer. So it will be extra expenses if I buy another K code card, guys. So it's much better if he can sell me plug and play ECM, guys. So okay, guys, wait for the continuation of this ECM. May part 3, maybe this part 3, yeah, part 3.